Balanced chemical equations. In our previous section, we have learned that how to write a chemical equation. Now in this section, we are going to learn about how to balance the chemical equation. Look at this chemical equation. Fa plus H2O gives Fa3O4 plus H2. It is a skeletal equation. Recall the law of conservation of mass that you studied in your previous class. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation balanced? Let us learn about balancing a chemical equation step by step. Step 1. To balance a chemical equation, first draw a boxes around each formula. The reason for drawing boxes around the formula is that when you are balancing in a chemical equation, you are not supposed to change anything inside the boxes while balancing the equation. Whatever balancing is done, it is done outside the box. Step 2. For this, first we need to draw a table which has 3 columns, such as element, number of atoms in reactants, and number of atoms in products. List the name of the elements in the column element. List the number of atoms of different elements present in the unbalanced equation. First, we start with Fa. Fa on the reactant side is 1, whereas on the product side it is 3. Then let's go to hydrogen. Hydrogen on the reactant side is 2, and on the product side also it is 2. Then oxygen. Oxygen on the reactant side is 1, whereas on the product side it is 4. If we see that the sum of reactant is 4 and the sum of product is 9. So in short, we can say this is an unbalanced equation. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. With the help of this table, we can identify the element has most number of atoms. Using this table, we select oxygen. There are 4 oxygen atoms on the product side and only 1 on the reactant side. To balance the oxygen atom, you have to note that balancing of equation is doing only by multiplication. To balance oxygen, we have to multiply the entire chemical formula of H2O by 4 and not H2O4 in the product side. Now the number of oxygen atoms becomes equal on both sides. But the number of hydrogen atoms becomes 8 on the reactant side. Step 4. To equalize the number of hydrogen atoms, multiply the number of molecules of hydrogen as 4 on the product side. Step 5. After that, number of oxygen and hydrogen atoms becomes equal on both sides. The number of iron is 1 on the reactant side, while it is 3 on the product side. To balance it, multiply the iron on the reactant side by 3. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. Now the number of atoms of each element becomes equal on both sides. Thus, this equation becomes a balanced equation. This method of balancing chemical equations is called hit and trial method. Now the equation is 3Fa plus 4H2O gives Fa3O4 plus 4H2. Step 7. Now carefully observe the balanced equation. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The physical states can be solid, liquid, gas, or aqueous. If a reactant or a product is in solid state, we have to write a small s besides it. If it is liquid, then small l. If it is gaseous, then small g. And if it is aqueous, then small aq. What is aqueous? Take example of salt water. Salt is in solid state. But if we dissolve in water, the state of salt becomes aqueous. So any substance dissolved in water becomes aqueous. Now the balance equation is written as 3FaS plus 4H2O gives Fa3O4S plus 4H2G.